For what values of x does f of x equal 2 cosine x minus root 2 times x have a horizontal tangent line? Give all answers in the interval from 0 to 2 pi. And give your answers as exact values separated by commas. Okay, so a function has a horizontal tangent line whenever its first derivative is equal to 0, because the derivative is measuring the slopes of lines, and a horizontal slope is 0. So we're just looking for where the slopes of this function are 0. So we'll start with the first derivative. So f prime of x then is going to be, let's see, 2, the derivative of cosine is negative sine. The derivative of root 2 times x. So this is polynomial based, even though there's the radical square root of 2. But it's linear, and so it's just the constant multiplier. All right, so I have negative 2 sine x minus the square root of 2. Now, the next step I need to do is set this equal to 0. So I need to take my derivative, set it equal to 0 to find these horizontal tangent lines. So negative 2 sine x minus root 2 equals 0. And let's solve. So negative 2 sine x equals the square root of 2. And then we divide both sides by negative 2. So I have sine x equals negative root 2 over 2. Now, you should know your trig functions, sine and cosine, on the angles, the standard angles in quadrant 1. That will satisfy all the different problems that you might be asked that involve trig functions in this class. You can figure out from quadrant 1 the different values around the unit circle, so that's fine. So the thing about this right here is I'm going to have a reference angle of 45 degrees because the sine is root 2 over 2 at 45 degrees. Okay? Now, the thing is, the sine of x needs to be negative. So all students take calculus. Let's see, all values are positive here, so that's not the right quadrant. Sine is positive here, so that's not the right quadrant. And then tangent is in quadrant 3, and cosine is in quadrant 4. So these are both what I want. Now, I need an angle measure that has a 45-degree reference, or pi over 4. Everything's in radians in calculus, but it's easier to think conceptually with degrees and then convert, I think. So I need a pi over 4 or 45-degree reference here. So this is effectively 180 plus 45, or if you want to think of it in terms of radians, that's pi plus, whoops, pi plus pi plus pi over 4, which is 5 pi over 4. The other angle here is 45-degree reference angle, but in quadrant 4. And again, that reference is pi over 4. Now, notice this is rotated in the negative direction, so we actually need to say that it's going to be 2 pi minus pi over 4. So 2 pi minus pi over 4 would be, well, let me be careful here. So 4, so 8 pi minus pi over 4, so 7 pi over 4. So there are my two angles, 5 pi over 4 and 7 pi over 4. And they're both in that range from 0 to 2 pi, so I do need to make sure I include both of